Hi everyone. Now let's discuss topic 2 of Unit 4, Tools and Techniques for Digital Forensics. NCASE, used for disk imaging, evidence collection and analysis. FTK, Forensic Toolkit, helps in file recovery, decryption, and email analysis. Wireshark, popular for network traffic analysis. Autopsy, an open-source digital forensics platform for investigating hard drives. Techniques like hashing, MD5, SHA1, SHA-256 are also critical, as they verify that evidence has not been tampered with. Write blockers are used to prevent accidental modifications to original evidence during acquisition. To make this clear, let's look at some exam-focused questions. 2-mark questions. Name any 2 popular digital forensics tools. What is the purpose of write blockers in digital forensics? Which tool is widely used for network forensics? What is the main function of NCASE? What is hashing used for in digital forensics? 5-mark questions. Explain any 3 digital forensics tools and their uses. What is the importance of hashing in digital forensic investigations? Compare open source and commercial digital forensic tools. Describe the role of live forensics tools in incident response. Explain the use of network forensic tools in cybercrime investigations. Digital forensics tools and their detailed uses. Digital forensics is a critical field in cybersecurity that involves identifying, collecting, preserving, analyzing, and presenting digital evidence in a legally acceptable manner. The right choice of tools depends on the type of investigation, source of evidence, and the legal or regulatory requirements involved. These tools are essential for reconstructing cyber incidents, detecting insider threats, and supporting legal cases. 1. Disk and data capture tools. Disk imaging tools create exact copies of storage devices, hard drives, SSDs, USB drives, or memory cards, without modifying the original data. These bit-by-bit copies preserve the integrity of evidence, which is crucial for legal admissibility. Examples: FTK Imager can create images in multiple formats and allows selective file captures. NCASE, popular for enterprise investigations, can acquire data from various devices, including encrypted drives. DD, Linux command line tool, performs raw disk copying and can be used in forensic pipelines. Example: if a company suspects that confidential files have been copied by an employee, a forensic investigator can use FTK Imager to make a precise copy of the employee's hard drive, ensuring the original evidence remains unaltered. 2. File analysis tools. Once data is captured, file analysis tools examine the file system to identify relevant evidence, recover deleted files, and search for hidden or encrypted data. Examples: Autopsy Sleuth Kit, useful for analyzing metadata, file timelines, and deleted files. X-Ways Forensics allows keyword searches, pattern recognition, and recovery of complex file structures. Example: in a fraud investigation, investigators might recover deleted invoices or emails that indicate financial misconduct using Autopsy. 3. Network forensics tools. Network forensics focuses on capturing and analyzing network traffic to detect unauthorized activities, data exfiltration, or malware communication. Examples: Wireshark captures packets and allows detailed inspection of protocols and sessions. Network Miner extracts files, credentials, and session information from captured network traffic. Example: if an attacker exfiltrates data over the network, Wireshark can help trace the path of stolen data packets and identify the attacker's IP addresses. 4. Memory RAM forensics tools. Volatile memory contains data about running processes, network connections, malware, and encryption keys. Memory forensics tools are critical for investigating incidents where malware resides only in memory. Examples: Volatility Framework analyzes memory dumps to detect malicious processes, hidden services, or injected code. Belkasoft Live RAM Capturer captures live RAM content for immediate analysis. Example: in a ransomware attack, investigators can use volatility to identify the ransomware process still running in memory and extract encryption keys for potential recovery. 5. Mobile device forensics tools. Mobile devices are primary sources of digital evidence due to calls. Messages, GPS data, and apps. Tools in this category recover deleted or hidden information. Examples: Celebrite UFED, extracts SMS, call logs, social media data, and GPS locations. Oxygen Forensic Suite provides detailed mobile app analysis and cloud account extraction. Example: during a corporate espionage case, investigators can recover deleted WhatsApp messages and GPS locations from a suspect's phone using Celebrite. 6. Email and messaging analysis tools. Emails and messaging apps often contain critical evidence of fraud, phishing, or insider threats. Tools analyze headers, attachments, and message content. Examples: Aid for Mail converts and analyzes emails for investigation. Forensic Email Collector preserves and collects email evidence securely. Example: if an insider sends sensitive financial data to a competitor via email, these tools can trace the emails, confirm authenticity, and recover deleted messages. Additional considerations: legal compliance. All forensic tools must preserve evidence integrity to meet legal standards. Automation versus manual analysis. Automated tools speed up collection, but manual analysis is often needed for complex cases like business logic abuse or insider manipulation. Cross-platform investigations. Modern investigations may require combining disk, network, mobile, and cloud forensics to reconstruct a complete picture. Overall example scenario: in a corporate data breach, an investigator may use FTK Imager to capture a suspect's laptop, Autopsy to analyze deleted files, Wireshark to examine network exfiltration, Volatility for memory analysis, Celebrite for mobile device data, and Aid for Mail to review email evidence. By combining all these tools, the investigator can reconstruct events, identify culprits, and provide legally admissible evidence. Key techniques used in digital forensics, explained with examples. Digital forensics relies on a set of well-defined techniques to ensure that evidence is collected, preserved, and analyzed without tampering. These techniques help investigators uncover the truth behind cyber incidents, fraud, or criminal activity. 1. Imaging and cloning. Imaging involves creating an exact bit-by-bit copy of storage devices, such as hard drives, SSDs, or USB drives, so that the original data remains untouched. This ensures the integrity of evidence for legal proceedings. Example: if an employee is suspected of stealing company files, investigators can use tools like FTK Imager to create a forensic image of the employee's laptop without altering any original files. 2. Write blocking. Write blockers are hardware or software devices used during data acquisition to prevent any accidental modification of the original media. They allow read-only access to the evidence. Example: before analyzing a suspect's USB drive, a write blocker ensures that even if files are opened, nothing is written to the drive, preserving its original state. 3. Hashing. Hashing uses algorithms such as MD5, SHA1, or SHA256 to generate a unique digital fingerprint for a file or disk image. Any change in the data changes the hash, allowing verification of integrity. Example: after imaging a hard drive, the investigator compares the MD5 hash of the original drive and the image to confirm they are identical. 4. Data recovery. This technique retrieves deleted, hidden, or corrupted files from storage devices. Specialized tools can often recover data that users think is lost. Example: in a fraud case, investigators may recover deleted emails or financial spreadsheets from a laptop using tools like Autopsy or X-Ways Forensics. 5. Timeline analysis. Timeline analysis reconstructs the sequence of events by examining file metadata, logs, and timestamps. This helps in understanding what happened when and by whom. Example: after a ransomware attack, an investigator can determine the exact time the malicious file was executed and which files were affected by analyzing file creation and modification timestamps. 6. Keyword searching. Keyword searching allows investigators to scan large datasets for specific strings, such as usernames, passwords, transaction IDs, or suspicious terms. Example: in a corporate espionage case, searching for keywords like confidential or competitor names in emails and documents can uncover evidence of data theft. 7. Live forensics. Live forensics involves collecting evidence from a running system without shutting it down. This is essential when dealing with volatile data in RAM or active network connections. Example, during a malware investigation, volatility can be used to analyze the RAM of an active system to detect running malicious processes. 8. Log analysis. Logs from operating systems, applications, and security tools are examined to detect suspicious or unauthorized activities. This can include login attempts, file access, or network connections. Example, if a user's account was compromised, reviewing authentication logs may reveal unusual login times or IP addresses, helping to trace the attacker. Overall example scenario. In a data breach investigation, the forensic team may create an image of the compromised server imaging, ensure no data is altered using a write blocker, verify integrity with hashes, recover deleted files, data recovery, reconstruct the attack timeline, timeline analysis, search for specific stolen file names, keyword searching, analyze RAM for malware, live forensics, and review system logs for unauthorized access, log analysis. These techniques together allow forensic investigators to build a clear, legally defensible picture of what occurred. Best practices for using digital forensics tools, explained with examples. When conducting digital forensics investigations, following best practices is crucial to ensure the integrity, reliability, and legal admissibility of evidence. One of the key principles is always working on forensic images rather than the original media. For example, if analyzing a suspect's laptop, investigators should create an exact bit-by-bit copy of the hard drive and perform all analysis on the image to avoid altering the original data. Another essential practice is documenting every step taken during analysis. This includes recording which tools were used, the commands executed, and timestamps of activities. Proper documentation allows the investigation to be audited and verified in court. For instance, when using autopsy to recover deleted files, every action should be logged for transparency. Using multiple tools to cross-verify findings ensures accuracy and reliability. For example, if a deleted email is recovered using X-Ways forensics, it can be cross-checked with results from FTK Imager or Encase to confirm consistency. Maintaining a chain of custody is also critical. This involves keeping a detailed record of who handled the evidence, when, and under what conditions, ensuring that the evidence is legally admissible. For example, each time a forensic image of a hard drive is transferred, the custodian should sign it into and out of storage. Finally, it is important to keep forensic tools updated to handle new file formats, operating systems, and security measures. For instance, an outdated version of Celebrite UFED may fail to extract data from the latest smartphone models, potentially missing crucial evidence. Conclusion: digital forensics tools and techniques are fundamental for investigating cybercrimes, detecting fraud, or resolving security incidents. By combining technical accuracy, like imaging, hashing, and write blocking, with legal compliance, documentation, and chain of custody, investigators can ensure that evidence is trustworthy and admissible in court. Choosing the right tools for disk, network, memory, mobile, or cloud forensics is essential for conducting accurate, reliable, and defensible investigations, ultimately supporting organizations in mitigating cyber threats and enforcing accountability. Thank you. Please like, share, and subscribe.